In third grade, we're working with multi-digit addition, and students are going to build upon what they learned in second grade and apply these methods to larger numbers. Third graders are expected to learn, understand, and explain each method, but are encouraged to use methods that make the most sense, as well as to include a proof picture when needed. So the first strategy is called Show All Totals method. This method helps children connect their understanding about place value to multi-digit addition. So the equation we're going to use is 247 plus 168. And we always encourage the students to write their problem vertically. So they would rewrite it as the same way, but just vertically. Then the first step we have them do is draw a proof picture. So next to each number, they need to draw the proof of each number. We have hundreds, tens, and then 7 ones. And for 168, so that would be their proof picture. Now what they need to do is add by showing all their totals. So digitally, they first start with the hundreds. So 200 plus 100 would be 300, and they need to write this entire number underneath their line. Then they move on to the tens place, and they need to think of these as tens. So instead of 6 plus 4, or 4 plus 6, it has to be 40 plus 60, and that equals 100. We also need to encourage students to line up their place values, so when they're adding the remaining numbers, they get the correct answer. And then the ones place, 8 plus 7 is 15. And then at the very bottom is where they add together all of their totals. So now they can add down each column to get the answer 415. Now, with their proof picture, what they can do is make groups of 10. So by making this group of 10, they need to have 10 ones. So here we have 8. We need to make 2 more for our group of 10. And this group is going to make a new 10 stick. We need to cross off this group to show that it's been used to create this new 10 stick. Then we go to our tens. Can we make 10 sticks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can, so we're going to circle that group, cross it off, and that's going to make a new 100 because 10 times 10 is 100. Now we need to see what do we have left. So we have 100, 200, 300, 400. We have 110 remaining. And we have 1, 2, 3, 4, 5 ones. The answers that the students get should match up. Okay, Owen, can you show us how to do the show all totals method for addition?
Yeah.
Owen's drawing a proof picture now. Realized he made a mistake, so he's going to fix it.
So I knew that 200 plus 100 is 300, and 40 plus 60 is 100, and 8 plus 7 is 15. So I got 415. My proof drawing is that So I put the 2 10s for 247 and the 4 10s, then the 7 ones. Then I said that because I did the 168 too, and I said that in my head that I had 8 ones, and I knew that I have 5 right here and 5 right here, so I circled that and got a new 10, and then I realized that I had 10 right here too, and 1 left, so I put a 1 down there, and there's 5 ones right here. Then I got 300s and 1 more 100, and that's 415.
Thank you, Owen.
The second strategy for multi-digit addition is called new groups below. And this is very similar to the original algorithm that many parents are used to using, but the extra 10 or 100 is written below the add-ins rather than above. So it looks like we'll use the same numbers, 247 plus 168. So we encourage students to start with the ones. So they're doing 8 plus 7, and this would be 15. Now, to support this answer, we also encourage students to draw their proof picture again. And the 168. So we show students the reason why there is a new group of 10 here is because when we group these ones in a group of 10 and cross it off, it makes a new 10 stick. But instead of originally, most parents are used to writing the 1 above, this strategy is called new groups below, and that 1 should go below the add-ins here in the tens column, showing that we made this new 10 stick. So now we can move to the tens, 6 plus 4 plus 1, showing it here. Can we make a group of 10? Yes, we can. With 1 10 stick left over, this will create a new 100, which shows us that 6 plus 4 plus 1 is 11. Okay, this new 100, which we created here, is now below the add-ins, and this one is this 110 left over. Now we can add our hundreds. 200 plus 100 plus another 100 is 100, 200, 300, 400, which is the remaining proof that we see in our picture.
All right, Abby, can you show us how to do the new groups below method of addition?
Sure. So what I did is I knew that 7 plus 3 equaled 10, and then I had 5 left over, so I put the 5 down here, and then I drew an arrow so I knew that this 10 had to go here, and then I knew that had 4 right here, and this with the new 10, it equals 5. So I grouped the 10, and I drew an arrow over here for 10, but then I also saw that I had 1 left over, so I put the 1 down here. And then I counted up the hundreds, and I just knew that I had 400. And so what I did to check my answer is I knew that 7 plus 8 equals 15, and I knew that the ones couldn't hold 15, so I had to put the 1 over here because it was a 10, and then I had to put the 5 down here. And then I knew that 6 plus 4 equaled 10, and that I had 1 left over, so it had to be 11. So I knew that I couldn't have 11 tens, so I had to put 1 over here, so it had 100, and then I put the extra 1 down here. And then I knew that 2 plus 1 was 3, so then I just had to add the extra 1, so I got 415.
Thank you.
The last method that we're using in 3rd grade is called new groups above, and this method is most familiar to a lot of families with their original school experience, so it looks familiar to most parents. When we're adding 247 plus 168, we're still trying to encourage students to draw their proof drawing, just as we've done with the other ones, to show and represent their numbers. Then it's very similar to new groups below, but instead of writing our groups below the add-ins, we're going to write them above the columns. So starting with the ones, 8 plus 7, can we make a group of 10? Yes, we can. We can circle our group of 10, and which would be 15. 5 ones are left over. We're going to carry that group, which created a new 10, above the tens place. Moving to the 10, 6 plus 4 plus 1. Can we make a group of 10? Yes, which is going to create the number 11. Cross this off, it makes a new 100. Notice we're regrouping and the new groups are going above. Now we can add our hundreds. 200 plus 100 plus 100 more is 400, and that shows us in our proof drawing that that's what's remaining, which hasn't been made into a new group. The only difference between new groups above and new groups below is the position of that 1 tally.
Hannah, can you show us the new groups above method of addition?
I did 7 plus 8 equals 15, so I put a 5 down here and a 10 up here because if I added a 1, still add a 1 down here, it'll be 4,115, so I put it up here. 1 plus 4 equals 5 plus 6 equals 11. 5 plus 6 equals 11, so 1, and another 1 up here. 1 plus 2 equals 3, plus 1 equals 415. And there was more than 10 over here, so I circled 8 plus 2, circled that one, and put it in the tens place. And then I know that there's 5 left, so I wrote a 5 down here. And then all this would equal 100, so I put it over here. And then there was 1 left from because there was another 10 over here, so I wrote 1. And then there was 400 because there's another 100 over here. And then 5 left, so I wrote 415.
Thank you, Hannah.